How many roots does this one have? 4. Why is it 2? What's the highest power? 4. So this is what we talked about, right? The degree, don't forget, is the highest power. Even if it's out of order, that was a great catch to Marcus, right? The highest power is the degree, and so 4 zeros, 7 zeros. That's all that we're talking about. And so when we're looking at the lesson that y'all have already turned to, page 139, we are looking at creating what kind of polynomials. It's all in that first objective there. What kind of functions are we trying to create? Higher degree. What degree have we already studied? We studied second degree, which was what type of function? Quadratic. Hey, you with me? Right? Second degree was quadratic. Have we just studied any other degrees? 0 and first degree. First degree was what kind of function? Linear, right? Y equals mx plus b. Nice linear function there. So we've already studied really low degree functions. We're going to learn how to create higher degrees, but we're going to really focus not just on creating them algebraically, but understanding what they look like graphically by focusing on what? The linear factors and the what of those linear factors? Zeros. Those are the keys that we are focusing on today, and we're going to go a little bit beyond that with that third objective, trying to figure out how these functions are increasing and decreasing based on those linear factors. We're going to start sketching things today. So we looked at this on Friday. Remember, we, if you were here, we looked at, nope, you can't see that. We looked at this file. You should already have your logged into your calculator, gotten this file open. If you have not done that yet, please do that. So remember, we had a constant function here. This was a degree 0 function. And what did we do? By the way, you want to flip in your book to page 140, I believe. Yep, looking at page 140. What did we do to that constant function? Preston? We added x, right? So we had f1 of x is equal to a, and then from there, we created a second function where we added x to it. Does anyone remember what transformation we call, or we see when we add stuff? Translations, right? So we translated by x. And so literally, and I'm going back through this because we need to pay attention to this. So later on, we're going to add functions in. So you hit menu, graph entry / edit, you go to function, and notice it says f3, but I want to look at the second function. You see how I've already set it up with f1 of x plus x. And there it is. And so what we literally did is, remember f1 of x equals a, which value is that then? A is my what? That's a y. Yep, that's it. That's a y. And what did we do to our y value? We added x. So we look at our y value, which is 3, right? And we added x to it, which is, what's 3 plus negative 2? 1. So what's the y value now? 1. Notice the x value is still negative 2, but the y value is 1. We translated by that value of x. Now when I change x again, let's not use that one, it's a little tall. So right now, my x is,
2.
my x is 2, y is
3.
So I take my y value 3, I add, translate it by my x value 2, and what do I get?
5.
So 1, 2, 3, 4,
5.
5, right? So when we translate by non-constant values, by variables, we are changing the degree of that polynomial. That's what we want to see here. That's conceptually what's going on. And so now, we are looking at slides 2.1, 2.2, and 2.3, 2.1 through 2.4. We're going to come back to the book. We're going to come back to 141 in just a second. But I do want you to notice here, we should be on 2.1. So if it did not automatically pop up, go to Browse within your documents. You are in Spring first block, so scroll down to that folder. And it's lesson 2. Okay. Okay, so if you have not gotten that file open, please raise your hand. Yeah, we should be on 2.1. Please raise your hand so that one of us can come by and help you open that file. Everybody good? Haley, you got it open? Mickey, you got it open? Yes? Alright, I want to make sure that we all have this open, otherwise the rest of this is going to get real tough.
Come on.
Okay, raise your hand. Ms. Bauer and Mr. Kilpatrick can come help you out. Yes. Who was that went?
Oh, wait.
Was it Grace?
No.
Anybody besides Grace go to the nurse's office? Anybody else missing somebody from the group? That's it?
I think it was.
I think it is Grace. I know someone else asked, but I think Grace is the only one that's still down there. Okay. So, go to page 2.2. Notice on the next slide, you're going to manipulate the sliders to identify what A, B, C, and D affect. Now, with this, please remember you need to move the cursor to hover over that arrow. You hold down the center pad until the hand closes, and then you can manipulate the sliders back and forth. So all we're doing right now, before we actually get into the meat of the lesson, is figuring out what do A, B, C, and D do. So manipulate it, talk with your group. I want to hear group conversation, trying to figure out what do A, B, C, and D affect. What are they controlling? Remember, we're on 2.2 now. 2.2. I need you playing around with the sliders. Don't make this hard. 2.2. Playing around with those sliders. What do A, B, C, and D affect? What do they control of each of those functions? Guys, I need y'all talking with your small groups. We should start to develop some ideas about what A, B, C, and D are doing. You don't have to write it down, we're just going to converse.
A move it.
I said,
I'm sick of it.
what's changing there?
I can't
I talk about lines of what increased, decreased. When we talk about lines of what turned it.
D move it to the left or right? My niggas
Girl, you need more emphasis.
What did you say? What did you say? Exactly. They move it up or down. Oh, versus number. Why are you saying diagonal?
They have the same chart. I was like to job yesterday.
It's good.
Thank you. Thank you. Sorry I did not get to listen to the conversations much, but who has a prediction about what A is doing to this function? Sanaya.
A is like that. Like this is going. I don't know how to explain it. It's swinging. Yeah, it's swinging.
It's making they're just excited.
Yeah, like
Okay,
that.
so
Like that.
it's not affecting the y-axis at all. It's what's a more mathematical term we could use to describe what's happening? Okay, maybe rotating. That's where we get the 360. But hey, guys, we're forgetting something. Like something I know that you know about this. First off, what is A controlling? Which of the functions? F1 of x?
Yeah.
Guys, look at A again. What is A controlling based on knowing what that equation is?
Show y.
Come on.
The X.
It's not, it does affect the x-intercept, but look at that equation. What is a control of that equation?
I mean,
The what? Ooh, guys, okay, pause for a second. What type of function are we looking at here? Both of them, what type of functions? Linear, thank you.
Oh, the line.
What about that line?
Line.
Not a concavity. I know it's got a, okay, the rate of change, but what is the rate of change of a line called? Say it louder. Slope.
you go.
Oh! I never heard you say that, that's why I got it. Guys, y equals mx plus b. What is a controlling of that line? Slope. Now, it's not affecting the y-intercept at all, but someone did bring up another feature that it's affecting. Because it's changing the slope, what else is it affecting? The x-intercept, right? But who has a question about why a is controlling the slope of that blue line? Alright, we need to pay attention to that. So based on the things we've already started to discuss, I will point out right now, what is my slope then? 1. Up 1 to the right 1. Up 1 to the right 1. Down 1 to the left 1. Does that have a slope of 1? Yes, Mr. Kenny. Great job, guys. What's my slope now? 2. Going up 2 to the right 1. Up 2 to the right 1. Is that a slope of 2? A is controlling the slope. Okay, B. What does B control then? Does B control the y-intercept? That's what Ethan is thinking?
Yeah.
Yeah? So what should my y-intercept be based on B right now? Does that look about 2.5? 1, 2, 2.5? Yeah?
Yes, sir.
What should my y-intercept be now?
5.
Sorry, I'm trying to get it to, there we go. 3, is it clearly a 3? Yeah, okay. Now, I do want to point out, right, when I look at this right now, what would the function be here? f1 of x equals?
What's that, Mr. Henry?
What's my function? 2x plus 3.
2x plus 3.
So what should my 0 be for this function? How would I figure it out? Say again. Something with the f. But guys, come on, what do we know about zeros? We just took a test that connects to this idea of zeros. Huh? We could get imaginary numbers, but guys, what do we know about zeros? F of x is what? Is y, which if I'm looking for a 0,
So it'll be 3. Will it be 3?
what?
Y equals 0?
Y is equal to what? 0. Oh, that's right. Zeros are because y equals 0. So how would I find my 0 now? Subtract what? 3. Negative 3 is equal to 2x now. Divide by 2, or you could remember to use that reciprocal times 1/2. Notice what's 2. That fraction bar is division by 2. That's 1. So negative 3/2 is equal to x. That's also negative 1.5. Does that seem to be what my x-intercept might be? Yes, right? So I'm pointing this out because this is going to play into today's lesson very heavily. So A is controlling the slope, B is controlling the y-intercept, right? And then this is how we would find our 0 based on that function. So what is C controlling for that red line? Slope again. Anybody want to push back on or ask a question about that? Tamar's like, yeah, I agree. Okay, then what is D controlling for the red function? The y-intercept. Thank you, Ethan. I'm glad we got one student who's, engaging. I know we just took a test, but we got to get to this learning stuff. So here's what I need you to look at. On the next slide, you're going to continue to manipulate the A, B, C, and D sliders to affect, to change. I don't know, it should be to affect or to change. to change the linear functions. What do you notice and what do you wonder about the dilation function f4 of x? So let's talk about that language just a little bit. So f4 of x, right? Here's f4 of x. Notice what's happening to get f4 of x. What do we see in the equation, Shania?
Which time is it?
So what's happening to get f4 of x? How are we getting this pink function here based on the right hand side?
F1 and F2?
F1 and F2 are being what? Multiplied, which should make sense because what operation creates a dilation?
Yes.
Multiplication. That's it, right? We talked about that on Friday. If you're talking about dilations, all we're talking about is multiplying. So what I need you to do is just play around with your sliders for A, B, C, and D, and ask yourself, what do I notice and what do I wonder? We want to find connections, we want to find patterns and relationships between F1 and F2 and F4. You don't have to have the right answer, guys, but I need you actively thinking and engaging and discussing, and then we will come back together, play around with those sliders, and pay attention to how do your functions connect to f4 of x. Alright, let's start manipulating those sliders on 2.4. Let's notice and wonder what connections do we see.
Why glitching?
Yours glitching. Let me come look at it. It ain't broke. Oh, just once you slow down, just look at it once you slow down. Because remember, we're just focusing on how do these F1 and F2 connect to that. Okay? Okay. A controls the concavity. Are y'all seeing that as well? A is affecting the concavity, okay? So, oh guys, one thing I meant to point out. Lily Kate brought up a good point. Think about the key characteristics of the functions. What are some key characteristics we should be looking at? Concavity. What else? Huh? The shape, the degree maybe. What else? The intercepts. The way it moves. But remember, okay, the vertex. So remember, I'm asking to focus on the key characteristics. Maybe a vertex, maybe intercepts, maybe concavity. How are these features of those lines connected to your parabola? Okay, sorry, keep exploring. We'll come back together in just a couple minutes. So what we noticed? There's only 2 lines.
I don't like this graph.
I can make you graph it by hand, but you prefer that? Okay then, stop complaining. What connections do we see between our linear factors and the graphic observations? Okay, so the lines are somehow in the middle of the parabola. Come on, think about your features though. Have you looked at your x-intercepts, your y-intercepts, your concavity? So when you move A from what? So when you make it
They look like
negative,
like crosses.
the concavity? I think it's down right now, isn't it? Or is yours up? Oh, it is up, okay. I will point out, so A is controlling the slope, right? Isn't the slope also of the other line affected by B? So maybe when you play around with A, B C controls the slope of the other one. Look at the slope and see how it affects. There's other features to think about as well though. What things are you noticing? Okay. Let me ask you this. Have you played around with C at all? C, does C also affect concavity?
wanna get fancy, girl?
Hey guys, if you're in different groups, we ain't talking to each other. We're talking within our group to talk about this math.
Wait, see, make it.
Maybe keep playing around with C. It affects something else. Also, we were talking about concavity. Have we looked at any other features like x-intercepts, y-intercepts, things like that?
What have we noticed?
Okay, so A and C, the slopes of the linear factors affecting the concavity. Have we noticed Okay, so let me point this out. It sounds like we're focusing on the sliders. Look at the graphs. Have we looked at how the x-intercepts or the y-intercepts of those lines are connected to our parabola? Think about that. Hey, Naisha, if we're in different groups, we ain't talking. Sanaya, you're only talking to your group.
We're talking about this meeting.
What have we noticed?
So we know
So, but have you looked at any other features? You have to hold this down. See when it creates that hand? Hold till it closes. Okay, and then you hit escape to let the hand go. Thank you. Thank you. Thank you. So let's talk about the features that we have noticed. I know there's one feature in particular that a lot of us have started to notice. So what feature is, so what is one thing we have noticed?
It shows.
Go for it. Okay. Somebody else. Marshall, it's time for the whole class discussion. What have we noticed? Okay, the parabola changes, okay? But remember, I want us to focus on key features of that parabola. What is changing what? So A is affecting the concavity?
Yeah.
Okay. Does anything else affect concavity?
C do.
C did as well?
Yeah, it did.
Okay, so
It wasn't really.
that's a thing we have noticed. Are there any other features that we have noticed as we manipulate the sliders?
vertex.
The vertex? What about the vertex?
What about it?
You move when you change.
What is changing that vertex?
When you change
Look like
D.
D.
D changed
Where?
too.
I believe
Oh.
B and D affected the vertex.
Yes, sir.
Did A or C affect the vertex?
No, sir.
No.
Sure about that?
Wait, C did.
Yeah.
Look at, I'm about to change A right now. Is that vertex moving? As I changed A, did the vertex move?
Yeah.
Yeah.
Yeah?
I don't see nothing.
You notice how when you move B.
But Miracle, look right here. You see that vertex right here?
Oh, that. Oh.
Well, I'm just saying, like, if you see my vertex right there.
No, I forgot that was what
You notice how when you move B,
I thought we
it
were talking about
also moves with
Okay.
the blue line.
What does?
The parabola moves with the blue line.
Okay, so it moves with the blue line, does it move with the red line?
No.
No.
Yes.
Yes.
Because I saw.
Don't make up y'all mind. Like y'all can
Okay, is that red line changed? Did that parabola change?
No.
Okay, guys, we're missing a key crucial thing, and this is
Oh,
something I
the
brought up.
red line don't try to go up and down with the blue one go side to side.
Okay. That might be something. Hey guys, let me ask you this.
Is that what it's doing?
Yes.
Hey, what allows us to calculate maybe where that vertex is? I will point this out. Right now, this may be a detail we're missing, but f1 of x, so if I'm looking at my parabola, f4 of x, what could I substitute into the place of f1 of x?
2. -2.
Negative 2 what?
And 1.5.
X.
X, right? Remember it's ax plus b, so minus 1.5. That's what f1 of x is. So what can be substituted in for f2 of x? Close. That's negative 0.8x. I definitely understand missing that decimal. Then,
2.0.
1.5.
that's a, yeah,
Oh,
1.5.
right.
So plus 1.5. Hey, does anybody recognize that at all based on things we've studied? Does that look like the factored form? Hey guys, what does factored form connect to very readily?
What's the root?
The roots?
The root?
Correct.
The roots of the parabola? Does anybody see the roots anywhere on that graph? Where?
So
right there.
And -1, yeah.
Somewhere around there? Right there, close to that?
Yeah.
Does anybody see maybe
The
how
other
the
one right there.
line is connected to that to those roots?
Oh.
Yes.
What do we see?
What line?
Everything.
Well, look at this line.
It intersects. Well,
Oh yeah, the blue and red line intersect both. Yeah.
So the blue and, come on, say it, the blue and the red line, remember those are my linear factors. They what?
Intersect.
They intersect where? On the x-axis, okay?
I'm tripping.
Hey guys, whole class conversation focus, right? How do they intersect? Where do they connect? My point is this. Are they the same as the parabola or are they different?
Different.
Same.
Different.
Same.
It's different.
It's the
I
same.
mean, look at that.
Oh, you say it's the same?
I want you all to look at your
How
graphs.
is it the same?
Look at the red line.
They're the same.
Does the red line have the same
Bro, my dad is
x-intercept as one of your parabola's x-intercepts?
Both lines.
The red does?
Dude, no, it's, how you want
Does
to
the
say,
blue?
I'm dead at it.
No, my blue was in the
What
high
the skinny guy
sky.
say?
Huh?
My blue don't intersect.
Alright, well, both of y'all, Kim. Ladies, ladies.
Is your,
Skinny ain't gonna be.
is your slope 0?
No.
People get real sensitive.
Check again.
Like,
Hey, okay, so, hey guys, if we're having side conversations that are not a part of the whole class conversation, you're going to make me come unglued. So, let's look at Naisha's really quickly.
Don't look at mine now.
You know
Is that because you haven't been doing it?
No, I have.
Naisha, I see the problem. Notice how your line goes all the way over to here. You see how that parabola is down here and coming all the way over here? You know where they're going to intersect the x-axis? The same place. Guys, I need you to understand this. Right here I have a factored form. And what do we know about the root from this factored form and the root of the parabola? They are what? They're matching. They're the same. What do we know about the root of this linear factor and the root of the parabola? They're the what?
And it's different.
I mean, are they?
No, they're not.
Let's look at someone who has a little bit closer. Are they different or are they the same?
Same.
Sorry, let me clarify. The two lines have different roots. Does the line have a different root than the parabola though? No, that is one of the roots. Does this line have a different root than the parabola?
No.
That's the other root. So here's the thing. If I were to give you just this equation, how could you sketch out the parabola that goes with it? Well, can you find the roots from these factors?
Yes.
What would I need to do to find my zeros, to find my roots of this parabola?
You take both of them
So they make both equal to what?
equal. 0.
But mathematically, we want to be careful about that. Remember, if I'm looking for a 0, what is f4 of x? 0 equals negative 2x minus 1.5 times negative 0.8x plus 1.5. What's going to allow me to set each of those factors equal to 0? Oh yeah, that zero product property. The product is 0. And so I can solve for my roots. Now, there's one last detail. That's something I was trying to get you to naturally see, but there's one last detail I want you to think about right here. This is important to actually be able to sketch it. So if I know my linear factors, boom, or if I know my roots, I can find the roots of that parabola, that polynomial. Okay? Right here though, I want you to notice this. If I look to the left of this root, right here, this linear factor, does that have a positive or negative value? If I'm looking at the y's, are those positive or negative? It's below the x-axis, right? So they're negative. If I look at these, are those positive or negative? They're negative, right? Guys, you need to pay attention to this. So if I take a negative value and I multiply it by a negative value, what do I get? And look at your parabola. Are those values positive or negative?
Positive.
Those are positive. But we have to get to this what? What is this called again? A root, or also a x-intercept, or also a,
Also,
starts with a z?
zero.
0, okay? So to go from a positive to a 0, that parabola has to be, does anyone know what we would call this?
Decrease.
Decreasing. To go from positives to a 0, that parabola has to what? Decrease. And it's not just going to magically change there, it's going to continue to what?
Decrease.
Decrease. But at some point, we know it has to get back to a what? 0. Oh, and also I do want to point this out. Sorry, I should have said this before. Notice right here. Are those positive or negative values? They're above the x-axis, right? They are positive. What are these right here?
Negative.
Negative. And what's a positive times a negative? See how these values are negative for that parabola. But then it's got to eventually get back to a...
Zero.
So if it's negative and it has to get back to 0, it's got to start to what?
Decrease.
Increase. And so what does it start to do after the vertex? It starts to increase. Right?
Yes. Sir.
Thank you. I appreciate it. So then I look at the 0 and I look to the right of that 0. Look at the factors. These values are what? Positive.
Positive.
These are positive. And so what's a positive times a positive?
A positive.
Look at that parabola. What is it? Positive and increasing past there.
Yes, Mr. King.
Thank you, Shania. Guys, that's what I want you to see, and I need you to understand, like, this is what we should see for all of our graphs, and we're going to write notes about this in the book. But we should see and understand that the roots or the zeros of that parabola, right,
Yes, sir.
would be the same as the roots of the factors. And if I have a sketch of what each factor looks like, I can just multiply the values, positives and negatives, to figure out the sketch of the graph. We only have a couple of minutes, so I want to just look at one example with y'all. So if I have this, oh, and by the way, you remember how y'all are saying that the slopes affected the concavity? Remember a x squared, so what the coefficient of x squared is, controls concavity. So what's negative 2x times negative 0.8x? Is that going to be a positive or a negative? It's a positive. So that actually gives me a positive 1.6x squared. A is positive, so the parabola should be concave up. But if this was a positive and this was a negative, that would give me a
Negative.
and that would be concave down. That's how that's coming about, is that those slopes are affecting the factors. Now, I want us to briefly look at this. This would be, here's y equals x plus 1. Okay, pause. Here's y equals x plus 1. Here is roughly y equals 2x minus 3. So where would be the zeros of those parabolas?
Would be the two.
The two what?
X-intercept.
X-intercepts. Right, that's all I need us to see to start. Now look to the left here. What's a negative times a negative?
A positive.
So we're starting the parabola as a positive, but it's got to get to the 0. What's a positive times a negative?
Negative.
So it goes into the negatives, but it's got to start to increase to get back to 0. And positive times positive? Positive. That's roughly what that higher degree would be. Notice, what's the degree of this factor? What's the degree of this factor?
Negative
1, but when I multiply a first degree times a first degree, it gives me a parabola, a second degree. We will do our notes from the lesson tomorrow. I'm ready to see y'all and get some learning going. Hope you have a great rest of your day.